So now we're cooking with INTUchef, cultural evolution. We're powered by Chef. I'm here with Saman Garg, Shashi Shalanev, Omid Tarani, and I'm Mike Thibodeau. We're going to go through a little bit of our journey, show you our collaboration workflow, show you the structure that we've used within GitHub to power this, show you our use of shared wrappers. Going to go into our development pipeline, show you some deployments, and then, with any luck, answer questions that you may have. So our journey, like any, is not a straight line, right? Evolution's not straight. It's not 1, 2, 3 success. It's a maze of twisty, windy passages all alike, some of them better than others. Intuit's a series of many organizations, some larger than others, right? And it just keeps on growing, keeps on changing, just like our tool sets. We're faced with dealing with many teams that are doing things their own way because they're at their own different phases of their journey. We have different silos that form around these teams. They're heads down, working hard, trying to get their tasks done. And as a result, the solutions that they come out with can be slightly different from the neighbors. They don't have time to ask the neighbors what they're doing. They don't have a way of sharing with each other or discovering what the others are doing. With those unique solutions becomes future work, right? They're all doing the same things over and over again, and it's just adding extra time. We don't have a sense of community. We don't have a way to reach out, a way to work together. So what we did, we set about saying, okay, can we change this? Can we do something differently? Can we make our culture different, a culture of sharing, a culture of working together, where there's a community that comes first? When we looked around at what was available, we found Chef. We found the Chef community. We said, yes. What we have is, we've been branding it INTUchef, just like any other package. You take your corp name and post and append it when you make changes, right? So we took Chef, and we said, okay, we're going to guide ourselves by a philosophy, a desire to change our culture. What we have now is rapid, reliable, enterprise-wide collaboration available. You can able to contribute without conflict, without that duplication of effort. What we looked at, when we looked hard at Chef's success, you see that its power is in its community. And so we said, okay, you know what? We're going to make sure that we have a ability to have a strong community. We looked at the cultural changes we wanted to make, and culture is really defined by your tools, by your language, by your customs. And so we said, you know, the common tools, the common language that's out there, GitHub, right? Standard Jenkins builds. We're using Chef Server. And with the release of the supermarket, we now have our own ability to really replicate that Chef community internally. All of our orgs, all of our BUs, all of our project teams are essentially like your own smaller companies that are using Chef, except it's inside. The team comes along who's going to use Chef. First thing we're going to do is look at the community. The community is core. The community is key. You're going to review, find the best thing that's there, the best thing to work with. We'll pull that right on down, right into our Git repository. No changes. If it doesn't have what we need, you're going to use wrappers. We're going to use wrappers to add those changes that we need if it doesn't quite do what we want. You come along working on your project work. Your project work is that extra bit that's not going to be found in the community, that small extra bit. And you're going to make use of those wrappers, make use of those community cookbooks. All changes, hard and fast, all changes go through the SCM. To get your changes out of your SCM and get them into your production systems, build's required. So Jenkins, right? Jenkins build triggered from your changes, validate, test it, publish it to your Chef servers. Now with our changes, with our Chef code out there on the Chef server, all our nodes can converge. Happy nodes, happy with us. Those cookbooks that we've produced internally, the wrappers that we've made, need to be found. With Supermarket, we have discovery. With Supermarket, we have resolution. So now an engineer who's sitting down and working doesn't have to pull down a large repo that has everything in it. They can individually work on one single cookbook, one single aspect, and let the tools in the ChefDK Bookshelf populate for them. When we produce something that we really like, and legal says we can, we now also contribute it back out to the community, out to GitHub. There's the source for you to look at, right over to this public supermarket. So now we're not just simply consuming, we're also contributing. When we've excuse me. One of the things that enabled this structure to emerge was using GitHub Enterprise specifically. We can't just share all our stuff out on the internet, but we can use GitHub internally. By using the teams and orgs within GitHub, we can define who's the members of the various project teams, who's able to commit, who's able to contribute, who's able to approve a change. We have 3 types of orgs that you'll see within GitHub. You have the community org, Chef Community. All it's containing is repositories for those cookbooks that came straight from the community, unmodified. We have the corporate org, Intu. That's basically holding all of our modified wrappers, all of the things we want people to be able to reuse. Excuse me. And you have your project org. Your project org is for your teams. And I jumped ahead. We use a naming convention where we say that the public chef community owns the namespace of a cookbook. If you're producing a cookbook for new technology and it's not out there in the public community, because this isn't secret sauce for Intuit, this is what enables Intuit to deploy its secret sauce. If you're producing some new technology, it should be out there in the supermarket, and that's where you're going to claim your fame, claim your name. Anything that's not out there in the supermarket has to be prefixed. Out there in the public supermarket is prefixed. So our corporate org prefixed Intu. When we start working on the wrappers, we're basically just saying, okay, we needed this cookbook. We found the best version that was out there. We have it reviewed. We have it in our GitHub repo so we can get to it. We create our wrapper cookbook, both specifically versioning so that any consumer of these shared components knows exactly what they're getting, when they're getting, and when another team member comes along in another team and wants to create a new version of this wrapper to add some different functionality, or they want to pull down a new version of the Java cookbook to gain whatever new functionality is in there, it's not going to hurt someone else. They're not going to be taken by surprise. You have to choose to consume. The default recipe within that wrapper, including the recipes from that cookbook, also including the additional recipe that we've created to add that functionality we needed. In this case, the JDK cookbook was not able to select a specific version of that JDK to install. It wanted to install the latest and greatest every time. In a company like Chef, you have to have strict control over when you uptake change. Having a recipe that was going to reach out and do something different whenever it was available is not easily accepted. So the reason we're creating these wrappers, we're adding missing functionality, number 1, making it easy to consume those cookbook upgrades, making it easy to prevent failures due to those dependencies of those cookbooks. For example, any cookbook that has multiple dependencies, if you're just using it right out of the box, you can't just pin to that one cookbook, right? Because if it doesn't call out its dependencies on another, you need to make sure that that wrapper is including all of those dependencies right on down. So you're saying that this set works. And last, to customize for Intuit, right? Customize for my corporation. When we look in the project space, we have Chef Repo, everybody's familiar with. We have cookbooks, right? We prefix and use the GitHub project name. This is going to be unique. We have GitHub Enterprise across our organization. If we were using public GitHub, it would still be unique. It's guaranteed unique. Nobody has to check with me that it's unique. Just by default, if they were able to use that name, it will be unique. We prefix the Chef repo. The Chef repo is a repo like any other, except it has no cookbooks. This repo is rolling up to the flat namespace of Chef. And since it's going to the flat namespace, we need to make sure that we prefix those things that can collide. If you're using roles, environments, and data bags, they must be prefixed. The node name, it's going to be a fully qualified domain name, so there's no worry about collision there. For the cookbooks, the same rule applies. We prefix when you're working on that cookbook for your project team, for yourself. But the content, there's no need to worry about that. A cookbook content doesn't collide. Only its name, only the object itself. I went a little bit too far, I think. With all these in place, the development pipeline is pretty easy to go from. Go ahead, sorry.
Whew. Good. Did you guys all get that? We're going to have a test at the end. Anyways, so my name is Omid. I'm going to go over a little bit of our development pipeline. And so I'll go over creating a cookbook for a new project, and we'll go through CI, getting our stuff to chef server, supermarket, and ultimately converging. Let's get started. Let's imagine we have a project called ChefConf 2015. And your boss comes to you, asks you to create a new cookbook for a Java application, and wants you to get it done by the end of the day. So what do you do? What do you need for any Java application? You need JDK, HTTP, Tomcat, and we want to go ahead and monitor those things. So let's install Splunk and New Relic. What else do we need? We need to deploy our code. So we'll also go ahead and create a deploy recipe. Now that we know what cookbooks do we need, let's get it started. We'll go ahead and create a project, project org. Right under that, we'll create a repo, Chef Cookbook repo. And that basically with the convention that we talked about. Remember the project name underscore the cookbook name? That's how we separate it. Now, this is a vanilla cookbook. Let's get started working on it to make it to our demo cookbook. We don't have much time. Let's fork this. We'll fork it first to our personal org. Then we'll basically clone it down to our workstation, development environment. Now that we have it, we have our vanilla cookbook. We can start developing. There's some key files, as you all know, that we need to work on. First thing, default recipe. What do we need to do? Let's get started. Remember, we talked about the Intuit wrappers, and we looked for those. So we created all these wrappers, Java, Tomcat, Apache, Splunk, and New Relic. They're already there. They're in our supermarket. The community created them, looked at them, tested them. They're ready. I'll go ahead and take a look at them. All I have to do, include it into my recipe. That leaves me a lot of time to go ahead and create my deploy recipe and include it in there. I'm done with my recipe. What's next? We need a metadata. We need to give it some more information. In the metadata, first thing I would say it's always a good idea to do, update the version of your cookbook every time you make a change to your cookbook. The other thing, let's set our dependencies. We set our dependencies, let's make sure we pin it. Why do you ask? If we don't pin that, somebody goes in there, makes a change into Java wrapper, what's going to happen is that we're going to get that latest Java wrapper. That could break our recipe. So we pin it so we can test it before we update the version. Last thing in here, we set up a couple attributes. Our source URL, issue URL. We'll show you guys a little bit later in the supermarket why we're setting this up and what benefit it's giving us. Wow, I'm done. Now I can go ahead and sit on, watch videos. Not yet. I need one more thing. If I want to resolve my dependencies, I need to be pointing to our internal supermarket. Why? Because our Intuit wrappers are only available in our internal supermarket. So what do? I make sure supermarket.intuit.com is set up in there. And last thing, I run my kitchen converge, kitchen verify. That runs my testing, makes sure everything is good. Now that I know my cookbook works, all I have to do, run a couple get commands, upload that thing up back to my personal org. I'm ready to play. The next thing would be our CI, taking it through CI, taking it to Chef Server, Chef Supermarket, and converging. Shashi is going to walk us through the next steps. Thank you.
Thanks, Omid. So now that we have a new cookbook developed. I will show a demo that will walk us through the CI pipeline that will test the cookbook and take it all the way through to the supermarket and also to the chef server. So this is the cookbook repo that I have. In order to submit the changes, I'm creating a pull request. These has all the changes that I need. And as a good practice, I'm updating the version to 1.1.10. So let's go ahead and submit the pull request. So as soon as you submit the pull request, the status of the pull request changes to pending by a CI job that gets kicked off. And this is the CI job that's basically validating the cookbook. As part of the validation, we usually run the kitchen verify and also food critic. This framework can be extended to run any other security testing or compliance testing that you may need. Upon successful validation, the status of the validation job gets updated back on the pull request. As we can see, the build got succeeded, and now we are able to merge. Typically, the person who submits a pull request doesn't have the ability to merge the pull request. For this demo, we made it simple. I have the ability to merge the pull request. So I will go ahead and merge the pull request. So when we merge, there is a different job that gets kicked off. We are calling it upload cookbook. So what upload cookbook does is takes the changes and it is uploading it to the chef server and also to the supermarket. Let's go ahead and review it. So this is the chef server that we are using, and now it has the updated version. Same with the supermarket. The demo app cookbook 1.1.10 also made it to the supermarket. So remember the source and issues URL that Omid mentioned about in the metadata file. It enables these tabs on every cookbook wherein you can go in and view the source of the cookbook. This enables faster collaboration, and people can go in and look at the source code for any cookbook rather than downloading the cookbook on their workstations. Another advantage that we get out of supermarket now is dependencies. You can go ahead and browse the dependencies as well, and also view the source code for the dependencies. Let's go ahead and review and summarize what exactly happened here. So we have the project org. We are making changes to any cookbook on our workstation. Once we make changes, we submit a pull request. The pull request actually triggers a webhook, which is executing a Jenkins build. The Jenkins build validates the cookbook with syntax and other verifications, posts the status back to the pull request. There is another gate, which is the manual review process. Upon review, the author would approve the change and accept the pull request. Once the pull request is accepted, it triggers a different build job that is uploading it to the chef server and supermarket. And once you have the cookbook in the chef server, the node could converge using the new cookbook.
Cool. Thanks, man.
Thank you.
So I think this is pretty sweet, because now we have the ability for any team at Intuit to sit down, create a cookbook just on their own, create a cookbook, add it to the build process, have it get all the way out and show up in the chef servers, right? We have a similar build process for the policy repo that I mentioned that just does different validation to make sure that there is no other collisions, no other problems. So they have full control over their content that's showing up on the chef server independently without having to ask permission, without having to coordinate. And so now everybody can work together at their own pace. But we're not doing this so that we can do chef, right? This is just like the beginning. We did all this effort with Chef because we need to manage our systems and deploy our secret sauce, deploy Intuit's code, deploy our applications. And so for that, you're looking at your application deployment. We try to use a similar model. Your engineers, everybody's practicing, CI, doing Agile, right? So they're checking in through their repo. All changes go through source code. CI build kicks off. You build an artifact. Your artifact goes to your repository so that your Chef nodes can converge and pull down that artifact. One of the stoppers that we face is how do you tell your Chef instances, how do you tell your cookbooks when they're converging in your node, which version of my artifact do I pull down? When you're dealing with your infrastructure, it's kind of easy, right? You've set it once, and it's solid everywhere, and it's within your Chef workflow because you're configuring policy about your application service, your host, your infrastructure. Here we're talking about payload, right? We're talking about the data we're pushing. Having that version number inside Chef as an attribute is a common way, but that means you're going through that whole Chef workflow on top of your validation build that you're doing with your systems. So we separate that information out, get it out of Chef. It doesn't belong in Chef, all right? That attribute doesn't belong as an attribute. So you've got some kind of a deploy engine that you're working with to manage those version numbers, to manage the deployment order, to say that it has to go to QA, has to go to performance testing before it can go to production. What versions are available for those artifacts? Rather than keeping it inside of the Chef server, we looked for a way to keep it outside. First, we looked at our repository. We said, hey, can we use the repository itself to tell us? But so far, that never worked out well. Looked around for other ways, came across etcd. This is a lightweight distributed state database. By leveraging the already existing Chef infrastructure that we put in place and putting an etc daemon on top of and at each of our Chef clusters, we scale with our infrastructure. When we have to add more Chef servers, we will by default be including the etcd at each one of those places. So it scales by default. We don't have to think about it anymore. Inside that etcd, we're storing the version number that's now available of that release candidate. We're storing the promotion order that you're going to be going to QA first, going to performance, going to production. We store whether it's actually deploying or not, right? So when my node goes to, excuse me, let's jump ahead. So now we have our versioning in there where it has to go. We know it's going to go to dev QA production. When my node goes to converge, we don't want them all to just converge all at once. We want to control it somehow. So typically, some kind of an orchestration engine, some kind of a push job, some kind of an action where you're reaching out and touching your nodes to tell them to converge. Automatic convergence isn't something that many people are comfortable with right away. It takes a long time to get there. We want to get a lot of teams working together right away. We want them to move as fast as possible, as soon as possible. With an orchestration engine, you're going to be reaching out and telling which nodes to converge. You're going to watch the state, watch that it worked. And they're going to converge, get that information out of the state table for what they should use, and deploy. When we have that concept of a state database on the Chef servers, then you start thinking, well, what else could we do? What else can we handle here? If we look close at the components we have, that deploy engine, can we do something different? What if we move that manipulation, that entry of the version and the deploy order earlier on in the cycle, right into the build of the artifact itself? So if the artifact build publishes that information, says, hey, I've got a new candidate, and here's where it has to go, we don't need a deploy engine anymore. It disappears. We're now using the existing build setup we already have for every artifact build. Well, if we think a little bit harder, we can say, well, this state table, what else can you do with this state table? When our nodes converge, they need to make sure that they're not all converging at once. So if we take that idea of a state database, instead of having a distributed state database that's running on the Chef servers, why don't we run it on every node? If we run it on every node, and they're communicating as part of their tier, that application tier, now you essentially have an application cluster where what they're sharing is Chef state, their run state, right? You're not talking back and forth to the Chef server. You're not using search. You're not using other expensive operations. You're staying as local as possible. When your node goes to converge, it can record its state that it started to converge. It can find out how many others of its peer nodes are converging. It can find out if it's able to converge or not. So now it can orchestrate itself. Orchestration engine goes away. Our nodes are self-orchestrating. One less thing we have to manage, one less thing we have to scale, one less thing we have to think about. When the nodes converge, they're tracking for themselves whether they can or they can't. They're reporting back whether they've succeeded or failed. This information locally is used for the peer nodes to decide whether they should or they shouldn't converge. When that set completes, the final node is looking back and looking at that state table and saying, hey, are there any other nodes that needed to converge that are recorded in here as nodes in my tier? No? All right, I'll report back to the distributed state that we're done. This tier is done. We're all updated. Now because the distributed knows, hey, that tier for that server is done, other nodes, other sites, other apps are able to use that information to take action next. So this orchestration isn't simply for one node, for one app, for one place, but it can extend to your whole enterprise. I think I'd like to show you a little bit about this now, and so someone's going to walk through a little bit of the use cases.
Okay, thank you, Mike. So let's take a look at some of the scenarios that your nodes may run into when it is trying to do the deployment in a self-orchestrated way. So here we have 3 application environments, dev, call, and production. Production is available in multiple sites, site 1 and site 2, each of which has multiple nodes in it. So Mike talked about the promotion order. So in this demonstration, we're going to assume our promotion order is dev to call and then to production. That means that production will not deploy the code until deployment succeeds in dev and call. And so now you have your artifact, which is sitting in your Nexus, in your artifact repository and waiting to be deployed. Say our pre-production environment wakes up and tries to converge, and it fails to do the deployment. It could have failed the test, or it could have been a bad build, which resulted in a bad deployment. Now what happens to your production? Now when the production tries to converge and wakes up, and it finds out from that shared etcd system that the deployment in the pre-production environment has failed, so it will not proceed with the deployment, and it will wait for the next run if you have fixed the build issues or if you have a new build that needs to be deployed. So now you go back and fix your build issues, or you fix your tests, or create a new build. And now pre-production deployment succeeds, and now production is allowed to promote the code because all the previous environments have succeeded in deploying. In this demonstration, we're going to assume that our goal is to successfully deploy the code in site 1. So now when site 1 wakes up and tries to do the deployment, it finds out that my remote site has already started the deployment. So what happens in site 1? Oh, before the site 1 starts, it finds out that site 2 has failed to do the deployment. And it gets that information from the same shared etcd system that we referred before. And then site 1 says that, oh, I can't do the deployment right now because my remote site has failed, and we all care about availability, right? So we want our site to be up all the time for our customers. Now let's take the best case. Our pre-production deployment has succeeded, and my remote site, it either has finished the deployment successfully or it hasn't started yet. And then one of the nodes in site 1 will wake up and try to converge, and it will find out that, okay, this is the version that I need to deploy, and my pre-production environment has succeeded in deploying. Now it will start the deployment. Now what happens if some of the other nodes in the same cluster in your same site wakes up and tries to converge? So Mike talked about the local etcd cluster that we have on our application servers. So the other nodes will find out from that shared etcd cluster that there is another node which is already trying to do the deployment, and it hasn't finished yet. So the next node will wait for that deployment to finish before it proceeds. So let's take a look at these use cases in action. Let's see if it really works. So in this demonstration, we are trying to launch INTUchef. Let's see if we are able to successfully launch it. Network, sorry. Sorry guys, just give me a couple of minutes.
The danger of a live demo.
Exactly.
But it's exciting.
But now you guys can see what I did behind the scenes.
Quick cut to the can.
Okay, almost there. All right. Okay.
Okay.
You all set? So we're going to take a look at the first use case that we talked about, that our pre-production deployment failed. Let's see how our production node reacts. So I'm just going to simulate the use case. Oh, come on. Okay. So I'm just going to set some bits in our etcd cluster so that we can simulate that use case. Now if I go back to my production node, this is my production node, and if I go and run chef client on this node, so the first thing that it checks is, it checks whether your pre-production deployment has succeeded. So in this case, we can see that it finds out that your call environment has failed to do the deployment, so it's not going to proceed with the code deployment yet in production, so it's going to skip this run. Now you go back and fix your build, you have a new build that's ready to deploy, but your remote site has failed to deploy. So what happens to my node in site 1? Let's run the chef client again. So it says, okay, your pre-production deployment has succeeded, but your remote site actually failed to deploy. So it checks it here, and it says, okay, I'm still going to skip the deployment until you have a working remote site or remote site succeeds in deployment. So if I go back to my site, we still haven't launched, which is what we expect. Now let's take the use case, the best use case, where site 1 is allowed to promote code. Now I go back and run the chef client. Now we see it does the check again. It finds out that pre-prod deployment succeeded, and it checks the state of your remote site, and it finds out remote site has not acquired the lock yet, and it has not started the deployment, so you're good to go. Then the next thing that happens is my site 1 acquires a lock in the shared etcd system to let the other sites know that it has started the deployment. And then, since we are talking about node 1, and this node 1 acquires a lock within the same application cluster so that the other peers know that I have started the deployment, so don't do the deployment until I'm done. So here it is trying to do the deployment. Let's see if we go to the second node. Let's see what happens. So now I'm on the second node in the same site 1, and it says that deployment is under progress on your peer. So I'm not going to deploy the code in this run. I will try it next time. Now let's go back and see whether our deployment succeeded. What do you guys expect? Work? So we successfully launched INTUchef. So it worked. And the last thing that Mike was talking about, so as part of each chef client run in that particular site, it checks whether all the nodes have successfully deployed the code. If it has, it goes ahead and removes the lock into the shared etcd system so that other remote site can start doing the deployment now. We'll see it here. Yep. So every client run checks that and removes the log so that other sites can do the deployments. So now we're going to have Mike do the last piece, and then we'll open up for questions.
I can remember the last piece. That's the wrong notes. So what we just showed you really is the full workflow, right? We've enabled our teams to act autonomously, to share, to move fast. We've removed some human elements that were slowing us down. The orchestration is now more reliable. It's based on the policy that's been put forth during the build. It's based on the success of the artifacts being promoted. We have the ability to onboard right away, all right, without having to ask permission. We have an integration with the supermarket, the public supermarket, as well as private supermarket. Our users can easily discover what other users have produced internally. We have a method for sharing. We have a process where we can work with our internal corporate teams to accept or recommend changes so that we can share something outside or so we can consume something for internal consumption, for internal use. We now have that shared configuration. Those problems that we were facing, that we were looking at, this rework is gone. The silos are coming down. People are becoming more and more confident. The community is building. The chef community plays no small part in that. The chef community keeps growing as more and more people contribute and give back. We're no longer doing that rework. The fixes are once. The fixes are done. We get to improve each other. You know, it's a happy land where we're living, and I'm pretty proud of these guys for all the effort that they've put in, just making this happen. That's pretty much that's pretty much our journey, and where we're at right now. If you have any questions, we'd be happy to try to give you more information. The question is, what kind of logging do we use for Jenkins? Login for Jenkins.
No, plugin.
Plugin.
So, to integrate GitHub with Jenkins or within Jenkins, what plugins are? So within Jenkins, we did not use any plugins. All we do is we parse the payload that comes from GitHub. We look at the event, if it is a pull request, if it is an open pull request or reopen pull request, we go ahead and run the build job. If it is a push, which is a merge, we run the upload job. So what I did not show you is there is a layer in between GitHub and Jenkins, which is a Ruby code, which is doing the parsing and also firing the builds. Does that answer? But there is a similar plugin available out there, which is GitHub Pull Request Builder, that will do the same for you. There are minor tweaks that you need to do to make it work with the GitHub Enterprise. It works out of the box for GitHub, Open GitHub, but for it to work with the GitHub Enterprise, you need to make minor tweaks.
All right. So there's nothing else then.
Back to it. So if I understand your question is that how does the global etcd know about the whole states of each system and all that? So every time the chef client starts running, it basically runs the commands to update the global database, and it gives it information on my environment, my DC, my host, and every single thing is set up. It basically just imagine a JSON format that it changes the value on that and it updates it. And then at the end of the chef run, it updates it again. I'm done, I'm successful, this is my new version, so on and so forth. Does that answer your question?
So also in addition to that, like when you are bootstrapping your nodes and when you're configuring your nodes and creating them, so as part of that run, there is a metadata that you need to set up in etcd so that etcd knows about your nodes. And then, as Omid was saying, as part of the chef client run itself, at the end of each run, it posts the data back to the etcd system. It could be a shared etcd system or your local application cluster so that it can inform the other guys. Yeah, the demo that we were doing, it was kind of a simulation, but as I was showing about the pre-production deployment, right? So my pre-prod nodes will update the etcd system so that my production nodes know about that data. we didn't have any reproduction nodes maybe in future.
I think yes. Yeah, the rules that are imposed are validated, because otherwise it would be a world of hurt. And it's only as many restrictions as absolutely required to enable the collaboration, right? You don't want to hamstring your developers, right? You don't want to slow down collaboration or creation. And so there's only as much restriction as required so that I can't accidentally hurt them, so that they can't accidentally hurt me, and so that we just are one happy progression.